Okay, number 11, it was from analysis, but integration and differentiation. So part A was integrate from 0 to 1, and that's the function, but they gave you a substitution of x equals to sine theta. So from here is that we are changing variables from x to theta. So it's better also change the limits, that step. So we draw that table. So you're coming from x going to theta. So when x is 0, when you put in here 0, you get your sine inverse of 0, which is 0. And when x is 1, when you put in here 1 sine inverse of 1, you get 90. But it's better we convert to radians. So 90 is pi over 2. So meaning we are going to change the variables also here. So from our x equals to sine theta, we shall be having now our dx equals to, when you shift sine, we get cos theta d theta. So coming back and substituting it in here, by the way, you can say let that be I, so that I reduce on the burden of writing everything. So my integral of I, see our limit now in theta is 0, then 1 is going to be pi over 2. So our x there is just sine x. Now we get sine theta over the square root of 1 minus our x is sine theta, but it is squared, so we shall get sine squared theta. Then our dx is cos theta d theta. Now to simplify, this will be so it's 1 minus sine squared is cos squared. The square root of cos squared will be cos theta, and this one, see, it's going to vanish, remaining with only, when you integrate 1, so you get in theta, plus when you integrate sine, you get a minus of cos theta, minus cos theta, but from 0 to pi over 2. Putting in limits, when I put in, I get pi over 2 minus cos of pi over 2 is 0. That is the upper limit. Then substitute in the lower limit, 0. Then minus cos of 0 is 1. And we get our answer as pi over 2 plus 1. If you want, you can give it to for the small places. Then our part B was about differentiation. We had y equals 2 of x over the square root of 1. Then we want us to express y dx in terms of x. So we start by taking sine back. Shall be having now and from here immediately we draw a right angled triangle to get the other missing side. So if this is my y, the opposite is x, the hypotenuse is, so that my missing side is the adjacent, which we know that to get adjacent, my adjacent squared will be, okay, adjacent plus the opposite squared will give you the square of the hypotenuse is 1 plus x squared. So that from there our adjacent is, this cancels, the square root of 1 is 1 because we are dealing with distance, so don't expect a negative. So from there I can immediately get my cos of y, which will be now adjacent of hypotenuse, so square root of 1 plus x squared. So from here, I see that to differentiate this, I'm going to use now the quotient rule. So this one becomes my u, this one is my v. So in differentiate side, we get now cos y, dy dx. Then we get our v. Now this square root is the same as a half. Differentiate u, which is 1, then minus. We get now our u, which is x. Then we differentiate this, which will give us half x squared, reduce the power by 1. Differentiate the brackets, which is 2x. The whole thing over v squared. When you square this, you get 1 plus x squared. But our cos y is here, which will be 1 over power half dy dx. So here I have, now this one is going to go with this to get that x squared, this and this to get x squared, to 1 plus x squared per negative a half over 1 plus x the whole squared. Now you see, I want to make dy dx the subject, so I'm going to multiply this here and here. In simple terms, I'm multiplying through by 1 plus x squared power half, and multiply it here, remain with our 1, which will give us dy dx. And multiply this here, you add the powers to get now 1 plus x squared minus, when I multiply this here, you see they are the same brackets, so I'll add the powers. A half plus negative a half, which will give me power 0. Anything to power 0 is 1, so I'll have that into 1 over 1 plus x squared. See, this will go. So now my dy dx will be 1 over 1 plus x squared. And so that was our dy dx. So that was number 11. Let us move to number 12. But if you want to see more about differentiation, you'll find them in our playlist there, and even the paper, the question paper, you're going to find it in the comment section there. Let us move to number 12.